I'll make myself the presenter, and then as soon as I get going on the record, can you just start the recording?
Sure. Which button is it? Let me see.
So at the top of the user interface for GoToWebinar, there's under the big play button, there's one called Start Recording.
Right, but now I think you unchecked it or something. Sure.
I unchecked it, but you should be able to just hit it, right? Just a second here.
No, the start. Okay. Well, it was there, and then you unchecked that button. It's gone. Now it's still recording. Oh, you're recording already? No, I didn't. Let's just start it. Is my screen showed already?
Yes.
Okay. Okay. So today's topic is 3D components in HFSS. The plan is to go through a brief introduction of this nice feature and follow up with a quick demo, estimately taking about 20 to 30 minutes. So what is a 3D component? Um, let's take a look at, let's say this Apple Watch here. It's a device. If we explode it up into detailed views, it is assembled by uh, numerous different little components, batteries, screens, chips, IOCs. So from the engineering perspective, um, uh, we need to do design a simulation on each of those components. Um, and most of the time, it's done by various of groups or various of different companies, vendors. Um, so how do we efficiently pass uh, the information of these components? Um, we can use build this new capability in ANSYS electronic desktop that's called 3D component. Um, this 3D component, it has a .a3D comp file extension. It can be saved and reused uh, for um, for later. It can be so that helps you share with partners, vendors, and colleagues. It it contains the information it contains. It has geometries, it has material properties, boundary conditions, excitations, and IP protection, um, meaning that it could be encrypted with a password, so that um, when you pass it on to your when you pass it on to your customer, um, without revealing what's really inside, they will only see your component as a black box. For example, the Internet of Things are very popular nowadays. Um, let's take an example of chip antenna. A chip antenna. We want to know what's inside the chip and what is the antenna. Uh, Simply put, an antenna is just the layout routing plus the chip antenna at at this location um, at the end of the routing. So when we trying to simulate chip antenna, um, for example, if I design this chip antenna and pass it to my customer, that that manufactures this chip antenna, we don't want them to know what's really inside the chip antenna because of the IP purposes, but we do want them to know the performance and the characteristic of our antenna to make a good chip. So we can use our 3D component capability to pass our antenna component so that they can do a full analysis on their design. I mentioned the encryption capability of the 3D components. Um, it is often used in antenna industries. So the original antenna simulation model, by using this 3D component capability, the geometry can be maintained, but the geometry may contain some sensitive IP that may make it difficult or undesirable to share with others. So with the encrypted model, it will still remain the full fidelity of original model encapsulated and encrypted, and still maintains visibility of the geometry, and fields are defined by original model creator, and it has a full 3D electromagnetic simulation done on it already before you passing it on. Once you pass the antenna on, um, you can install the antenna on the on the antenna pool, and with everything being said, it still maintains accuracy and details of the original component, but without exposing sensitive IP. So this is the basic idea of this 3D component feature. Let me show you a little example of what I meant. Um, right now, I'm showing uh, a side view mirror on a car. It is it is a 3D component already. If we, I will start from the beginning, from the import. Um, Here I can insert a new HFSS design under Draw. There's 3D component library. You can browse it to where the 3D component is sitting at. So upon importing, it will give you a list of the parameters in this 3D component, as well as the image of the 3D component with info. Sometimes it will be encrypted, so the information will be listed here. But here it's not really that IP sensitive. So now I have imported this 3D component. Let's take a look at what's inside. So now this project contains this 3D component. It has a excitation right here. We can see that's a lumped port with an antenna with an P5 here, and everything else is just uh, a part of the CAT. So there's the PCB representation here, and the mirror, and the internal, and the body of the side view. And let me switch to a. So now we can simulate this. This antenna is supposed to be tuned at 0.8 gigahertz. Um, let's see. we take a look at S1 parameter, we see a nice dip plot that peak performance is approximately at 0.8 gigahertz, which is good, very good enough. We can also um, plot the total 3D total gain of a 3D polar plot, as well as the direction. That's this is the uh, this is the vertical direction of the antenna performance. This is the elevation. Just by looking at these plots, it's not very straightforward. We can plot this upon uh, our 3D geometry. By doing so, we just click on Overlay Visibility. So we can see that the antenna's performance. We can also put the 3D polar plot here as well. So this will tell us uh, how the antenna performs. Um, with everything being all set, we can further add this side view mirror to a full car model, um, which is open here. So as you can see, there's a let me turn off the plot here. So let's see, we have a representative full car model here. Um, this is also imported, and we also have a the side view, the left side view mirror uh, imported here as well, and can set certain boundaries. That we set a perfect electric boundaries on the full car model. Side view excitations is inside the side view mirror. Of course, we can do a parametric setup to do a parameter sweep. After everything's being all set, we can we can plot we can plot the antenna radiation pattern. Of course, we can also have this overlaid on our actual 3D model. So this will tell us how this antenna performs, radiates, how the signal of this antenna radiates when it's being placed on a car. So, so far I've shown you how to import a 3D component. On the other hand, how do we create a 3D component? It's also very easy. For example, if this is if we were to make a 3D component out of this entire geometry, all we need to do is select all the components you like and go to the same uh, drop-down menu, Draw, 3D Component Library, and we create a 3D component. Okay, so this message tells us you cannot create a 3D component upon a 3D component. So this is my mistake, but we can, let's say if we open something else, we can create another 3D component. Um, let's create another HFSS instance. Let's say we can import something from here. Um, let's take the same side view mirror. Well, that's already a 3D component. Let's take a separate CAD just to see. Okay, let's say we take this. Too big. Okay, let's just take the same side view mirror. We can do that. Or we can do this. We can make a random geometry. Let's say this is a component we would like to reuse time over time. Then we can create a 3D component upon this. Before that, maybe we can set a excitation, say on a surface. Say there's a wayport here. Okay, and maybe we can create an earbox, and then we can give a boundary conditions on this earbox. Okay, let's say this is the component we'd like to create. Now we create a 3D component with with a model that's a cylinder, and there's an airbox boundary. There's a radiation boundary on the airbox, wayport on the top of the cylinder. No hybrid region, no mesh operations, just one coordinate system that's global, no parameters. Encryption. We can give a encryption here. We can set a password. Let's say 1 1, and we can allow whether the component to be able to be added. It could be either never or with a user password. That's up to you. Um, so the first password, the upper password allow the use, the lower password allow the edit. So let's say we don't need, let's say we set them to be the same. There are just one. And licensing, we don't need any licensing information here. And the image is just a box. And now we save it, let's say on here. Okay. Now we can create a new HFSS just to import this 3D component. Okay. It requires a password to use it. Remember we set it to be 1. Okay. Now it's imported here under 3D components. It's here. And if it allows it, we can add a definition, which means we can always edit the 3D component. We set a password to be 1. So a separate project opens up, allows you to edit your 3D component. So this is a nice and neat feature. Allow the vendors, suppliers, and customers to pass their designs, and so without revealing any IPs. Um, in the industries, people use this function a lot, and we highly recommend and advocate these features to our customers. Um, if, um, this is all I have for today. Um, if you have any questions, you can. I'll leave 5 minutes for you to raise questions. You can put that in chat or in the question section here, or if you have questions later, you can send a email to support@ozeninc.com. Without further ado, I'll stop right here. All right, thanks for joining this webinar this week. We'll have other webinars in the following weeks. Feel free to join. Have a nice day.